Hello everyone and welcome to the next lecture of control systems. In this lecture, we will discuss the system response characteristics. In the previous lecture, we discussed the introduction to control systems and we also had discussion on the block diagram of control system. And we know that if this is the block diagram of any control system, then on this side we have the input or the stimulus to the system, and this is the desired response that we want from the system. On this side, we have the output or the response of this system to this particular input, and this is the actual response that we get from the system after the process is done. And we also know that the difference between the actual response and the desired response is the error of control system. Now, in this lecture, we will discuss the variation of output with respect to the input in a graphical manner, and we call it as the system response characteristics. And we also discuss the factors due to which an output vary with respect to the input, and we will also have the discussion on the procedure that a control system undergoes in order to generate an output. So let's start with the help of an example. Suppose we are at the ground floor of a building and we wish to move to the fourth floor of that building. Then in that case, we will enter to an elevator and we will push the fourth floor button inside it, and in response to that, the elevator will start moving upwards gradually, and after some time it will reach to the fourth floor. Now we can represent this phenomena with the help of this particular graph, in which the y-axis represents the elevator location and the x-axis represents the time taken by the elevator in order to reach to the fourth floor. The push to the fourth floor button is the input, which is represented as a step command, and in response to that, the movement of elevator from the ground floor to the fourth floor is the elevator response. Now we can observe that the elevator response is quite different than the input command, and this is due to two factors that make the output different from the input. And the first factor is input changes instantaneously but the output changes gradually. When we enter inside the elevator and we push the fourth floor button, then the input changes in an instant. But in response to that, the movement of elevator takes some time in order to reach to the fourth floor. We all know that the elevator can't directly jump from the ground floor to the fourth floor. It has to cross the first floor, the second floor, the third floor, and then after that, finally it reaches to the fourth floor. And that's why it takes some time. And due to this, the output response or the elevator response is quite gradual in nature. The similar thing happens with any control system. Whenever we apply any input command, the input is instantaneous in nature. That is, the desired response is instantaneous in nature. But the output of any control system is gradual in nature, because the control system has to do some work in order to generate that output. And that's why the output response or the actual response of control system is quite different than the input. Now we can observe one more thing in this elevator response, that it is having two different versions. The first version starts from the ground floor, that is the origin, to this particular point up to which the elevator has not finally reached to the fourth floor. That is, it is continuously moving upwards. And in the second version, it is finally reached to the fourth floor and it has stopped. We can say in this particular version of the graph, the control system is doing some work in order to generate an output. But in this version, the control system has done its work and it has generated the output. So we can say that this particular response lasts for a short interval of time in which any control system do some work in order to generate the output, and this particular response that lasts for a short interval of time is called as the transient response in the language of control systems. Whereas this particular response in which the control system is finally stopped, or we can say the system has reached to the steady state, is called as the steady state response of control system. This is the response when the control system has finally reached to the steady state, or we can say the final output has been generated by the control system. In this case, the output is the movement of elevator or the position of elevator in front of the fourth floor level of the building. So now we have understood that this particular response lasts for a short interval of time, and we call this response as the transient response, And this response is a permanent response of system, and we call this response as the steady state response because the system has reached to the steady state. But there is one more factor that can differ the output from the input in the steady state of the system, and this is the accuracy of the system at steady state. In our example, this corresponds to the floor leveling accuracy of the elevator. When we push the 4th floor button of the building, we desire the elevator to be in front of the 4th floor level of the building. But in response to that, the elevator is slightly below the 4th floor level of the building. So, we can say this is the desired response of the system and this is the actual response of the system, which is slightly different from the desired response. So we all know that the difference between the actual response and the desired response of any control system is the error of that control system. And we can say that this system is now in the steady state, so the error occurred in the steady state can be called as the steady state error. In some cases, the steady state errors are acceptable, but in many cases, the errors are to be reduced and we use certain system configurations in order to reduce the steady state error of any control system. We will discuss the system configurations in the next lecture. So up to now, we have discussed that the response of any control system will be slightly different from the input, and this is due to two different reasons. The first factor is the instantaneous nature of the input but the gradual nature of the output. We also discussed that the output has two different versions. The first version is from this point to this particular point that we call as the transient response because this response lasts for a short interval of time. And in the second version, we discussed that the system is finally reached to the steady state and we call this response as the steady state response. So in this lecture, we have discussed the variation of output with respect to the input in a graphical manner, and now we are done with this lecture. In the next lecture, we will discuss the system configurations. We will have two system configurations. One will be the open loop configuration and the other will be the closed loop configuration. And on the basis of system configuration, we will have two different types of system. One will be the open loop system and the other will be the closed loop system. Thank you for watching this lecture. I'll end this lecture here. See you in the next one.